I'll start with a quick presentation just to give a better idea of what LWK is and how it fits into the Liquid ecosystem. So first of all, if we think about Liquid, we know that Liquid enables a series of advanced features that are extremely useful in the ecosystem of this new way of using financial instruments with less trust involved. So with Liquid, you can do generic multisig, and in general, you can use complex scripting, which might have time delays or even more complex things such as covenants. With Liquid, you also have hardware wallet support, so you can move your signing material to a dedicated device. In Liquid, you have issued assets, and you can create them, you can issue them, and you can create more of them. You can reissue them or even burn them. You can also do swaps of this asset with other assets on the Liquid chain. So, for instance, you can offer to swap some Liquid BTC for some Liquid USDT in case and this happens in a completely non-custodial way, in a purely peer-to-peer fashion. You have also more complex use cases, such as lending and borrowing, using Liquid asset as collateral. And you can also create, sell, and move around derivative contracts, such as options. And there are even more applications that Liquid has. All these applications, however, are not that easy to develop from a developer perspective, from like a company that is using Liquid to do their business. And one of the reasons is that we have Blockstream do not provide tools that are very specific to certain use case. In some sense, we provide tools that do all the things on a low-level scale, so they can do very granular thing, such as signing or blinding a transaction, and this action can be done with the low-level libraries that Blockstream develop and provides, such as SecP, ZKP, Rust Elements, or libwally. Then Blockstream also provides some high-level wallets, which kind of do everything. These are the Elements core wallet and the GDK or the green wallets, let's say. These wallets are they provide end-to-end functionalities. They are like ready to use for users, but they are hard to customize. And if they need to be slightly modified to add another use case, such as swaps or handling option contracts, it's very hard to do that starting from those, which make the life of a developer kind of hard, because either they need to use low-level tools to build everything from scratch, which is very hard, and it's very easy to do in an unsafe manner, or they must use something that is very complex and it's kind of easy to customize for their needs. LWK aims to fill the gap between these two concepts, and it takes a different approach with respect to these two others. So LWK is a collection of Rust crates which can be used as a tool to build Liquid wallets. And to define them, to construct them, we decide upon a series of principles that we want to be the guide for the development. So first of all, we don't want the tool to support both Liquid and Bitcoin. We want it to be Liquid only, because Liquid wallets are the Liquid wallet tooling is what is missing in the wild. Then we want it to be modularized, so that you, the developer, will only need to use the part that they are interested in. They don't have to get the whole thing altogether. And we want to also keep complexity as low as we can. And in order for this to be maintainable with a cost that is not exorbitant. And also we want that to be interoperable. We want to follow and define a Liquid standard that should be common across wallet applications. We decided to use Rust to have an easy to build toolchain and to have a faster and safer development. And then we also want the tool to be easily extendable. So we want things to be easy to customize for certain use cases. If someone comes up with a use case that Liquid might be useful for, we want to provide the solution for common problems, such as coin selection, such as fetching data from a blockchain source, and so on. So here is a list of the features that LWK has. So first of all, we leverage a newly introduced standard, which is the confidential transaction descriptors. And with that, we gain two things. First, we gain watch-only access. So a wallet is defined by a descriptor, which is basically some information plus a series of XPub, which basically define the public part of the signers that are involved in the descriptor. And with descriptors, we also get the flexibility of having any kind of wallet, from a simple single sig to generic multisig like 2 of 3 or 3 of 5 and so on, to even more complex script, such as the one involving covenants, opcodes, or involving time delay, for instance. Then to get the information moving from the one that is constructing a transaction and fetching blockchain data, so the watch-only wallet, to the ones that are supposed to sign the transaction, so the signer, we use the PSET format, which is the equivalent of PSBT for Bitcoin, and it stands for partially signed elements transactions. And this basically encodes the information which is necessary for the signer to inspect the transaction that is being signed and decide whether it should sign it or not. Then another problem that for instance, the Elements wallet has is that it requires a full node, a synced full node to fetch blockchain data. For some use cases, this is not ideal. It doesn't work well with like mobile wallet or wallet that have some restrictions for in terms of bandwidth, for instance. And in that case, for that case, we use lightweight backends, and as of now, we support Electrum and Explorer. But our interface is general enough that they will be able to support an Elements backend too. But the idea is that within LWK, the syncing part will be confined outside. So within LWK, it just do wallet stuff. Then we added support for the asset lifecycle management of issued asset. So you can do issuance, reissuance, and burn transaction within LWK, and we have support for that also for hardware signer. The signer in LWK can be basically of two types, either a software signer, so a mnemonic that is, or a seed that is stored in the device on which LWK is running, or an hardware signer, so a dedicated device such as Jade, which can sign. As of now, we only support Jade, but there are more hardware signer which are in the pipeline. We also wanted to focus on binding so that people using the various crate could access those in the language they are more fluent with. So as of now, we have bindings in Python, Kotlin, and Swift, apart from, of course, Rust, in which LWK is written in. And we are planning to add support for more bindings. For instance, as of now, the Bull Bitcoin team is developing a Dart interface for the bindings, and we also have WebAssembly support. So for the web developers, we have worked for in order to get LWK to work also in the browser, and this allows web developers to basically paste a watch only liquid descriptor into the browser and get the balance for that. For instance, this is one thing that you can do, but you also can connect a Jade with the browser and do the things in the browser and then sign with the Jade device and with the security that it comes with. Of course, all of these things are not all bundled together. We have different crate so that if you just need to get the balance for a certain descriptor, because maybe you are maintaining a donation page or a wallet that is not supposed to ever sign, it's just supposed to receive, then you can just use a single crate. And if you want to work on a signer, you can use only the signer crate, and so on. However, to get all the things in a form in which they can be used, we decided to also add support for a JSON RPC server and a CLI which is able to talk to it. So that is what it will be used for the demo. It will be a CLI demo, so in the terminal, and we will use that. And the idea is that LWK provides the CLI interface and the JSON RPC server, but that's not the whole LWK. All the components could be used independently and at the need of the developer, which is interested in using this tool for his Liquid Wallet application. So this is just a very, very quick presentation. So LWK is a collection of Rust crates, and it aims to help Liquid developer to build their Liquid Wallet application. LWK follows a few principles. Liquid only, so no Bitcoin support. It's modularized so that you can pick only what you need. It is interoperable so that it doesn't force you to other people who you are interacting with to use LWK. It focuses on maintainability, and also it wants to be easy to build, test, and extend. We want external contribution, and we don't want the external contributor to be knowledgeable about the whole LWK architecture. If someone only need to deal with the signer part, it just need to be comfortable with that part of the code in order to provide some contribution in that sense. LWK targets mainly developers, but which kind of developers? Kind of any developer which is working on a Liquid Wallet application. So it could be a backend developer, for instance, someone which is working on an exchange integration. It could be a mobile developer, someone which is asked to do a liquid wallet, perhaps a very simple one with just which just sends and receive liquid Bitcoin. But also web, because we have WebAssembly support. People could do things such as getting the balance from the Jade and getting address and so on. So many other stuff. Also embedded, because we are while dealing with the Jade, we provide some kind of facilities that might be useful for in order to interact with it. And we are kind of the Jade interface for Liquid is slightly complex, and we aim to simplify that a bit. The idea, in that sense, is the one to that should lead us to define an elements HWI, so an elements hardware wallet interface. As of now, we only support Jade, so that's that will happen a bit later. But as soon as we have another hardware device, we will try to do the elements version of the HWI version, which is for Bitcoin, of course. And then developer should be also both from Blockstream and not from Blockstream. LWK aims to be something that it's focused on the community. The final thing that I want to stress out is that LWK should be the place to look if you are going to build a prototype on a liquid wallet. It should be easy to build and extend, and if you're willing to do like a proof of concept for some kind of application that might be interesting for you, LWK it's the right place to look at, because it should be easy to extend for your use case, and you can use it and all its facilities for testing to assess that your prototype can actually work. So that concludes the presentation part, and the next step will be a demo. The demo will be split in two parts. In the first part, we will create a 2 of 2 wallet with both a software signer, so a signer with which has the signing material, the secret, which is on the device on which LWK runs, and a Jade. So a signer where the signing material is on the Jade side. After this first side, I can get some questions if there are some. And the second step of the demo will be an issuance of an asset using the 2 of 2 wallet. So an issuance with the Jade signing the issuance. So first of all, we are going to start the server. So okay, this presentation assumes that you have the LWK CLI already installed. You can install with cargo install LWK CLI. That this will install the last release that has been done. You might want to add the -- features serial if you want to have Jade support, because it needs to right now it only communicates with serial. Bluetooth communication is on the go, is on our roadmap. And oops. Apologies. Let me check. Otherwise, you can install from source using this command. Everything is documented in the repo, and I have it already installed. This is the help command, and now I will start the server. Let me see if it's already running. I don't think it is. It is not. I will start it. I will start it and put the server in the background with the last character. So now if I ask the LWK CLI, how many signers did you have? It will tell me 0. So in LWK, we have these two concepts. We have signers and we have wallets. So the signers are the things that are capable to sign. And the wallet is the thing that is capable to generate address and fetch the transaction for a certain wallet. A wallet is defined by a descriptor, by a confidential transaction descriptor or liquid descriptor. And a signer is basically defined by its secret. In the case of a software signer, which is the first one that we are going to generate, so we can generate a secret. In this way, it will return a BIP39 mnemonic, 12-word BIP39 mnemonic, and then we can load it. So I will not use that. I will use another so that I will have my wallet already signed, already funded. So we want to load a software signer. First, we need to provide the name of the software signer. We will call it SW for brevity, and then we will specify the mnemonic. I will have it. I have it here. Of course, we are in tested right now, so these funds and secrets are worthless. If you apologies. I need to also specify whether I want to persist or not the wallet. In this case, I want to persist it. It's not ideal. Persisting it's not ideal. So it will persist the mnemonic at the moment in an unencrypted fashion. If I wanted to do things in a more serious way, I could generate the mnemonic, then encrypt it, for instance, with GPG and store it locally or with my password manager, and then just say persist false here. And across the start, the signer will not be remembered, and I have to load it each time. But that's might be acceptable in certain sense. In these settings, I will just allow it to be persisted. So it returns me some information about the signer. Let's gather a bit more. So I want to get the details of the signer. The signer is called SW, so software, and yeah, we'll get more information. So for instance, the fingerprint, the ID, which is like the long format of the fingerprint, the mnemonic since it's stored in memory, and the name, the type, and the master extended public key. So now we have the software signer loaded and ready to perform some actions, and we want to create the Jade signer. So you don't see it, but I have my Jade plugged in. The Jade, now I'm in testnet, in a liquid testnet, and my Jade is configured to be in testnet. And now to load the Jade, things are slightly more complicated. And we need 2 steps. The first step is to get the Jade ID out of the Jade. So now you don't see it, but I'm inserting the pin on my testnet Jade. It will take a bit, but almost done. Okay, so I inserted the pin correctly, and the Jade ID returned the identifier for the Jade. Now I'm going to load the Jade, and it's a signer command. I want to load the Jade, and I will name the signer Jade, and I will provide the ID. Et voila. Now we want to get the details of the Jade just to see the things that are different. So we see that the name is Jade, we have the fingerprint, and of course we don't have the mnemonic. The fact that we don't have the mnemonic is due to the fact that the Jade itself has the mnemonic, so you can't get it. even if you have physical access to the machine, you can get the mnemonic out of the Jade, and so we don't display it. And we can see both signers here. And we see that we have both signers loaded in the LWK CLI. Now we want to create a multisig. So to create a multisig, we have a facility function, which is under the wallet subcommand. So we'll just show the help. So we need to provide basically the descriptor binding key, which basically makes a confidential transaction descriptor different from Bitcoin descriptor, from regular descriptor. And we can choose between different values. And then we need to specify the kind of the wrapper. For instance, right now you only have the option to choose with within a script hash, and then we can set the threshold, and then we can specify multiple times the XPub from each signer. So first, let's get the XPub from the signers. So let's get the XPub from the software wallet. We had to specify a kind. We will choose BIP87 since it's the one supposed to be used in multisig setups. And here we have it. And then we do the same for the Jade. It will take a bit longer since it's actually asking the Jade for that extended public key. So we have them both. And now we are going to write the command. So let's specify key origin, and here is one, and here is the second one. If I haven't mistyped anything, it will return a descriptor. Now we have the descriptor and we want to load it. This function just generates the descriptor string. We need to actually load it. Of course, this function has some kind of limitation because it's not super general. If you want to create a very specific descriptor, maybe you will not be able to do that with that function specifically. So we can load a wallet. We will name this wallet multi, since it's multisig, and we'll specify the string of which defines the wallet, the descriptor, basically. So now we have it. Let's get the details of the wallet. Wallet details, and let's specify its name. So, okay, we have the descriptor string, which is the one that we set before. Then we have the type. It's a witness script hash multisig 2 of 2. And then we have the name of the signers involved. The signers are loaded, and thus we have the names in here. Of course, if one of these two signers was not loaded, we wouldn't know the name. We would just know the fingerprint. The fingerprint basically was get from the key origin part, which is basically here and here. So we need to do another action right now because we want the Jade to be aware that it is part of multisig. Otherwise, when it will be asked to sign a transaction and recognize change outputs, or when it will be asked to confirm an address, it will not know how to generate that address. We basically have to say you are in this specific multisig with this other XPub. So we want to register it. So the command is LWK signer register multisig. We specify the name of the signer, so Jade, and the name of the wallet, so multi. So now you don't see it, but locally on my Jade, I have a register multisig request. It specifies the name, which is the same one that we registered, so multi. Specify this is a 2 of 2. It says the blinding key, and the fingerprint of the first signer, other information such as the extended public key, the same for the second signer, and then it just asks me to confirm, which I just did. So now the Jade is aware of the multisig. Let's get an address for this wallet. LWK wallet. The command, of course, is address, and we need to specify the wallet name. So we have an address here, and however, sometimes I want the address to be. I want to confirm the address on my device, on my sign-in device, and this can only be done, of course, if it's an hardware wallet. So we specify the signer. The signer is a Jade, so I can do that. If I do that, oops. Okay, move the cable too much and it unlocked. I'm unlocking the Jade again since I, oops, apologies. Let me try again because I set the pin incorrectly. Okay, let's try again. Okay, I'm locking the Jade. Okay, I'm verifying the address right now. Okay, I can do it again since it showed me the address on the Jade, and then it shows it on the CLI due to the way the CLI works. But this can be worked around in an easy way. Now I can check that the address is the same and confirm it. I can check that it ends with XG336, so it's correct. Cool. Let's get the balance. Okay, the balance it shows the asset ID in X format, but that is LBTC, and I know that, so I can specify it in this way. I can just have the tickers displayed over there. So I did things incorrectly, and this was is not funded. So I will fund it right now. And so let me grab the address again without confirming it again. I will display and send some funds. Okay, we'll use my mobile wallet, should be faster. I will send 10 milli liquid Bitcoin. Okay, transaction has been sent. So let me check the balance again. It will take a bit to update. Okay, now it has received the funds. And now that the funds are in the wallet, we can continue and do the issuance. I've just had a look at the chat and I saw no question, so I guess I'll proceed. And in case I see some question, I will perhaps stop and go back to it. So we have some fees, so we can do an issuance transaction. First, we want to create an asset that has some that can be registered on the asset registry. So we want to create a, we want to specify a contract. So to do so, we have an utility, and we could do that with this command. So LWK CLI asset contract, and we need to specify some things such as domain, the issued public key, name, the ticker, and so on. I've already set few ones, and I will just paste it here. So the domain will be example.com. We are not going to actually register it. We could, but it's outside of the scope of the demo. And then you have the issued pub key. This one is one that works. And the name will be the demo LWK, and the ticker the LWK. So this is the contract, and we are going to actually do the issuance right now. So LWK wallet issue, and then we need to specify the name of the wallet, the Satoshi that we want to issue. So Satoshi asset. We want to issue 10 of this demo LWK asset. And then we want to issue also one ration token. And we also want to specify the contract. So contract here, and I will just paste it here. Okay, cool. We have a PSET has been created. So we'll just save it to a variable. Okay, let's analyze this PSPT. So we can do that with LWK CLI wallet PSET details, and we specify the name of the wallet since we want to basically get the net effect of the PSET on the wallet. We specify the PSET, and we also want to have the with tickers flag so that we see what's going on there. Okay, let me, oops. So the details are quite long, and I don't want to resize my screen. So we see that we have two new assets that are coming to the wallet. One of the is the ration token, and one is the asset that is being issued, and the fee is expressed in LBTC. In this case, is 387 satoshis. And it also specified that there is an issuance in this transaction. And there are two fields which are particularly interesting at the signing phase, which is the as signature from and the missing signature from. We see that it has no signatures, and it is missing signatures from Jade and the software wallet. And the next step will be to pick this PSET and get the signer to sign. Of course, in this demo, the signers are within my machine, are local, but they could be anywhere. For instance, I could be one of the co-signer, could be someone else. I should be sending him or her the PSET, and I will get the PSET signed back, hopefully, of course. So let's get the PSET signed. So to have the PSET signed, we specify, we need to talk with the signer. So the signer subcommand, we need to specify that I want the PSET to be signed. We want to specify the software wallet. Now it's going to sign. And we want to specify the PSET. And so we will pass the PSET, which is over there. And this will have, this will make the software signer sign. Let's wrap it in another variable so that we don't, we are not, things are a bit more tidier. And we can do the very same thing with the Jade. Of course, we will name the PSET in a different way. We will simulate the fact that the signer are, my signer kind of in a parallel fashion. So they're signing the same original completely unsigned PSET. And so the new signer will be the Jade. This will take longer because the transaction will be signed by the Jade itself. So it will ask me to confirm stuff. So I'm being asked to confirm that this transaction is sending 10 the LWK, which is the Asian transaction, to a certain address, and also the address for the Asian token. I'm confirming also the fee, and I'm sending the transaction. This is not actually sending the transaction; it's only signing it. Let's get the details of these two. So let's also just look at the. Let's see them all. It's better. Oops. That's incorrect. That's the details. Okay. Okay. So now we can see that it has signature from PSET1 as signature from the software wallet, and it is missing the signature from the Jade. While the other, it has the opposite. So it has the signature from the Jade, has signature from Jade, and it's missing the signature from the software wallet. So what we need to do now is we need to combine the two, and we can do with this command, and we're going to combine the two PSET in a PSET that will have all the signatures. And let's check it again. Okay, so it has signature from both the signers, and it has no missing signature. So this is ready to be broadcasted, and it's what we are going to do. So LWK, CLI, wallet, broadcast. We specify the wallet name, and then we specify the PSET that should be broadcasted, so PSET 3. And voila, we have a new transaction. Let's we can check the balance. So now we check the balance. What you expect is a bit less LBTC and some more of the newly issued asset and the Russian token, and that's what we got. So let's use the with tickers. Okay, so we have the LBTC which have been decreased, and we also have the Russian token, which is 1.4 and some other, and the asset, which is the other one. Now, everything is done, but we would like to do a bit more. So as of now, the asset is not registered in the registry, and sometimes you don't want the asset to be registered in the registry. But because maybe you want to do things in a slightly more private way, but we use the contract, so we could have the tickers which is corresponding to those assets. So we can insert them. So let me pick a couple of notes. So we need to get the Asian transaction, and we can get the transaction with this command. I will just paste it. And no, this is not correct. I need to get the correct. Apologies. Okay, I need to get the correct transaction ID, and here we are. So we got the transaction. Let me just check that the transaction is there. Yes, it is. And then we want also the we need the asset and the contract. Okay. Okay, we have the contract, we want the asset, and yeah, then we need to do LWK, asset, insert we need to specify the asset ID, and the asset ID is this one. Then we want to specify the issue transaction, which is TX, and then we want to specify the contract. Oops. The contract is this one. Okay, perfect. So now we want to get the balance with the tickers, and we now have the tickers. So these tickers are provably committed to the asset ID, so you can't lie about those. This last process is a bit convoluted, but if you will register the asset to the registry, you will be able to use this command. So where you just need to specify the asset ID. And this will be the most common use case, since often you will not be the one issuing the asset. You just want the asset to, you maybe just receive the asset. I mean, asset issuer are more infrequent with respect to asset user. So yeah, I can see the list of the assets which are known to my LWK CLI instance here, and also I can see a list of my transaction, and I can specify the wallet. Oops. Of course, it's just the excess. I want to have the tickers. Okay, so I can see the balance of the transaction I have. So in this case, the issuance transaction. And I can also see here the unblinded URL. So the links to blockstream.info with the unblinding information, which are only used on the client side. So if I use this link, I can see that I can see the input and output that I own unblinded. And yeah, this is the first transaction, which is the funding transaction. So a transaction which has a net balance for my wallet of 10 liquid millibitcoin. Cool. So that was the end of the demo, and I will answer some of the questions that I see in the chat. So the first question is, what's GDK and LWK compatibility like? Those two who have already built their liquid wallets on GDK, do you recommend moving? So GDK support for Bitcoin and liquid. LWK has only support for liquid. GDK has support also for the for a wallet that use the green backend. So now we are talking only about liquid. We have put the Bitcoin stuff on a side, and for those we don't have full interoperability, since it requires us on some things that are done specifically by the green backend, and so for those stuff cannot be migrated if people want to. However, for the single sig part of GDK, LWK is interoperable with that, in the sense that the descriptors that are that comes out of GDK can be used in LWK. For instance, let's say that you want to have like a donation page, or a page where you display addresses, and and a service where you can see the balance. Basically, you want to have a watch-only entry. You can get the descriptor, the confidential descriptor from GDK, and use it in LWK. So in terms of moving, it really depends on what you want to do, and there are still some differences between the two, and there are pros and cons. One of the cons that is worth mentioning of LWK, since we want to be honest, is that LWK is a very young project. It started less than a year ago, and we have like ambitious target and which are quite wide, and not all the things are perfect yet. While GDK is has more years of development within it. Then, second question, can you talk about more feature coming? Okay, existing in the blog post, it mentioned plans for the existing protocols such as LiquidX, as well as any Covenant-based protocols. So the idea, so for what concerns the roadmap is quite sparse, let's say. So we want to add support for more other wallets. So we want to add an alternative to Jade. We want to improve the way the internals are built. We took some shortcut and we need to address them sooner or later. Then for what concerns bindings, we want to add more bindings and refine them in a better way. Of course, do so we would really benefit from some contribution from someone who is using those languages on a daily basis, because sometimes things are done in a slightly different way if you're using Swift or Kotlin or some other languages. And then we also want LWK to be something on top of which things can be built on. And among these things, we can put the swaps, which can be done with LiquidX, and Covenant-based protocols. However, there are different phases of doing it. So the first phase is like you want the internal part to be compatible with the protocols you can build on top, and then you want to drive a bit of UX from the implementation. This is something that it's not that easy, because it's not clear in all situations where some things should be done. Let's do one example. For instance, in LiquidX, when you do a proposal, you are willing to exchange one UTXO for another one, something that for you is equivalent to it. So, for instance, I want to switch my UTXO, which is holding 1 milli liquid Bitcoin, for the equivalent in liquid USDT. So, but I mean, at a certain level, the wallet should be aware that UTXO was out for a proposal, and if I spend that UTXO in another manner, that proposal invalidated, which is okay, but sometimes it's not what we want from a user perspective. So it's delicate in that sense. So there are plans to add support for LiquidX, but we need a couple of more of technical steps in between. But it's among our priorities in the short term. For what concerns Covenant-based protocols, one of the issues that arised is that anyone who was building them was kind of reinventing the wheel again and again, just creating another wallet. We saw that with the lending and borrowing protocol by Dmitry Petrukov, which was using his Python library. And then for the options, we had another wallet which was developed for that case, and it also was using Elements Core wallet, which some of the things are not ideal in that sense, and we want LWK to be the piece of software that is solving the common problem to all these use cases, and the one that might arise further on. So that if I want to build a lending protocol, I don't need to re-implement the way I fetch data from a blockchain or I issue assets. I just need to do the things that are specific to my protocol. Then the third question, is LWK compatible with AMP assets yet? Will it be added? There are some rambling about AMP2. Can you speak more on this? So as of now, LWK is partially compatible with AMP, the existing AMP assets in this sense. So if you are an AMP end user, like if you are someone that is using AMP via your green application, or you are kind of only receiving some securities which are issued on via the AMP service, this cannot, I mean, you will not be able to use LWK. This is because you need to use a GDK-based wallet for this. However, if you are an issuer and you currently need to use Element Score, you could switch from Element Score to LWK. However, that would be kind of a partial solution for us, and that's why we have in the pipeline to work towards a solution which will make the life of issuer a bit easier, and it will make things a bit more general in that sense, which is basically AMP2. AMP2, it's basically a cleaner way to do the things that AMP does, and it is solving some of the issues that issuers and people dealing with AMP has had in these years and that we collected. So AMP2 will come when? Don't know. It's been worked on, and we will, as soon as we have something that is decent to put out, we will put it out in testnet mode so people will be able to interact with it, and we will be in the position to gather feedback and to do things in the way, in the best way, in order for AMP issuers and users to benefit the most out of it. The last question, will Green move to LWK? Are there any liquid apps that are currently using or has planned? Green will not move to LWK in the short future. Green has his own specific things which LWK is not capable of supporting, and also Green needs support for Bitcoin, which is not something that LWK is doing. Anyway, LWK is interoperable enough that perhaps some part of it might be used by Green in the future, but as of now, it's not among our plans. And for what concern liquid apps that are currently using LWK, we have the Bull Bitcoin team, which is willing to add support for Liquid, which is using LWK. Specifically, they are using we are using the they are using their Dart binding implementation of LWK in order to integrate Liquid in their app. Also, there was some interest from Bolts, and also LWK will be there is some work in PeerSwap in order to remove the need for the for PeerSwap users to use to have a Elements node synced, and they will be able to use LWK instead. I mean, of course, it will be optional. Where can people get started? People can get started. I will share my screen at I will share another screen at our GitHub page, and let me. Okay, so I will move to that. So we have a GitHub page, and this is the best way to start to interact with LWK. So it outlines some of the things that have been discussed today, and it defines a bit of the structure of the repo and a way to run tests and so on. So this is the best way to start, and I think the best way to experience LWK is to use it in testnet. I mean, we provide everything that developers need, and so people can just try to issue their asset, reissue. If they have a Jade, which could be used for this purpose, they could use Jade within it, and they can start building things. And if there is something that is not working correctly, or they have dubs, or documentation is insufficient, they can raise issues or ping us on the Telegram chats that we already have. I think these are the two best places. And if people are starting to working in a more organized way, of course they can reach to us directly, and we can assist them with some better support, let's say.